to the panels here. This is what we're going to x-ray. So we're going to shoot our x-ray through here. Our film is going to be underneath this test tool. So we're going to take an x-ray of this test tool. What are we going to do with that film? Where's it going?
Chemical
In the processor, and we're going to analyze the effective dimensions of the focal spot size. Okay? Do you remember as a kid, elementary school, when there was a solar eclipse, we'd go outside and the teacher would say, look up at the sun because we want you to burn your eyelids? Did they do that? How did you guys observe the solar eclipse whenever you guys went outside?
I don't remember ever seeing
You guys
it.
don't remember? How was that? You put a hole in a piece of paper. You guys are looking at me like I don't know what I'm talking about. Yeah. So you take a piece of paper, you punch a hole in it, okay? And instead of looking at the sun, you're just looking at the light that's being projected through the hole. Look on the ground, and you can actually see the dimension of the eclipse on the ground. So instead of getting a full circle, you'll see like a partial circle like that. And you leave it there long enough, you can see the eclipse occurring as time passes. And eventually there is no light going through the hole, so you won't see any light illumination on the ground. Next time it happens, do it. Okay? Don't look up at the sun. Okay? Pinhole camera does the same thing. So we're going to put the x-ray on top of the hole there, take an x-ray of it, and then develop the film. Okay? The developed film will have the exact dimensions of the focal spot size. Same concept. Okay? That's using a pinhole camera. And then we already know about the resolution test pattern and line transformometer. All right, so now if I were to give you a set of factors like this again, can you guys tell me which will give me the best detail? You guys are familiar with this, right? Okay, let's just pick a range again. Let's do 1, 2, 3, 4. Let's do 1 through 4. 1 being bad, 4 being the best, so worst to best. What's going to give us the better detail? Small or large focal spot size?
Small.
Small. All right, so let's do small. 4, 4, 3, and 3. Okay? Long SID or short SID? Do we want our X-ray tube as far away as possible or as close as possible?
It's far.
As far for best detail. So we'll give 4 here, and these are all 3s, right? Everybody agree? Okay, short OID. Do I want my part close to the image receptor or far from my image receptor?
Close.
Close. So short OID. 4, 3, 3, 4. Okay, let's just add it. What do we have? 12, 9, 7, 9, right? Am I doing this right? And then 6 and 10. Did I do that right, guys? Huh?
10.
I can't add. What? 7, 10,
That
right?
was 10.
What's this one?
10.
This is also 10?
Yes.
Okay. This is 10? Okay. How about that one? That's right, right?
Yeah.
Okay. So which is going to give us the best detail?
The first one.
Okay. So this is going to give us the best detail. What's going to give us the worst?
Second one.
This is going to give us the worst right here. Okay. You guys know how to do these now, right? And then, I think there's, oh, the numbers are right here. Okay. Anode heel effect, we already know about the anode heel effect. It's a variation of the X-ray intensity along the longitudinal tube axis. Where is it most intense?
Cathode side.
Towards the cathode side, less intense towards the anode side. Okay. Now, what I also want you to know, oh, sorry. Is that the anode heel effect is going to be more apparent, which means more obvious, with lesser anode angles. What does that mean? Well, let's just say we have a great angle that's like this, and we got one that's less angulated, more steep. the greater the angle as it interacts, the beam is going to be wider, correct? What's in the middle?
Your central.
100% is your central ray. Greater intensity on one side, we'll just call this 175. And then weaker on this side is 75, but it's gradual. Okay, it's gradual. Now with steeper angles, because the beam is going to be tighter, here's your 100, here's your 175, and here's your 75. It's not gradual, it's more obvious, it's more abrupt. Okay? So with steeper angles or less angles, the anode heel effect is going to be more obvious, more apparent. You guys got that? With steeper anode angles, it's going to be more apparent. Okay. So again, you're going to use the anode heel effects, put the thicker side of the body part towards the cathode end, such as the T-spine, the femur, the chest is another example. Okay. More pictures with the hip towards the cathode end. Okay. These are examples. If you didn't use your filter and if you didn't use the anode heel effect, you're going to get a film that's very, very dark. This is more even in density. You guys see the difference, right?
Mm-hmm.
Okay. All right. That's what I just drew for you. So with greater angles, the effect is gradual, but with shorter, steeper angles, it is more apparent. So with that said, if the anode heel effect is more apparent with smaller tube angles, does it also affect the beam size?
Mm-hmm.
Yeah. What is this called? Do you guys remember week 1, week 2, week 3?
Line focus principle?
Line focus principle. You guys remember that? That's the line focus principle here and how it affects the anode heel effect. Oh, you guys are good. All right. Boom, boom, boom. All right. Lastly, motion. Do we want motion? We don't want motion. Or do we?
This is fluoroscopy.
Okay. So for the most part, we don't want motion. So how do we control motion? Because motion deteriorates our image, right? So how can we control that?
The timeline?
Time, shorter time. What else can we do? Threaten your patient? Okay. I don't call it threatening, but communicate with your patient. Let them know what you're going to do. I'm going to be taking an x-ray. I want you to hold still for me. Don't move. Hold your breath. If they're not able to control that because of maybe some muscle spasms, they're young, they're elderly, short exposure time is not going to work, use tape. We carry tape with us all the time. You know, nurses carry their forceps and their stethoscopes. We carry tape. Okay? So patient instructions, immobilization devices, sponges, sandbags, tape, Velcro, sheets. Okay? And then hold still, don't move, and
So even with the exposure times being as quick as they are, like just fractions of seconds, you guys still get.
We can still get it. So the question is, even if we use really short exposure times, can we get motion? The answer is still yes. You still can. So you want to use your resources as best as you can to minimize that. Okay. Here's an immobilization device. It's known as a pigostat. And here's the concept. If you get motion on your image, you'd have to go back and shoot it again, right? What does that mean for patient exposure?
Increased exposure.
You're doubling your patient exposure by repeating an exam. Especially with kids, we want to minimize it as best as possible. We put them in immobilization devices such as this. It's known as a pigostat. Don't ask me how we got the name, but it's a pigostat. You got your plexiglass, which is radiolucent. Arms up. We restrain our patients. They're sitting on a bicycle seat, so we can rotate our child facing forward, backwards, or on their side. And we get it done right the first time. No motion. Yes, the parents are going to look at you and they think you're torturing their kids, but the bottom line is it's better than having to go back and redo it again and re-exposing the child. Okay? I'd rather get it done right the first time than having to go back and say, you know what, your child moved. Okay? Now they're really pissed off at you. I would rather them be pissed off at me for using that than pissed at me for re-exposing their kid. All right? And lastly, before I let you guys go, I think this was photoshopped. I've never had a kid smile when I come in. Never. Never, ever. They're yelling and screaming. All right, guys. So we have a test on the material, Unit 4. Radiographic Technique 1, 2, and Radiographic Quality next week. All right, guys. Have a great